All right, stats fans, we're back at it. Continuing on with confidence intervals. So today we have our learning targets on the top left here. We're going to interpret a confidence level in context. We're going to analyze, and we're going to describe the sample size, how the sample size and confidence level affect the margin of error. And then we're going to explain how practical issues like non-response, undercoverage, response bias can affect the interpretation of a confidence interval. So in this activity, we're going to be using this applet that we have a link to right there. And we're going to learn what it means to say we're 95% confident that our confidence interval captures our parameter value, the true mean or true proportion. So go ahead and click this link here. We're going to change the method from proportions to means. So we should get this right here. Oh, my head's down below. There I am. Hello. And so we change that to means. We want to make sure the confidence level is set at 95%. So we want our confidence level at 95%, and so it is. And we want our N to be 100. We're going to click sample, and it's going to choose a simple random sample and display the resulting confidence interval. Confidence interval is a horizontal line with a dot representing sample mean in the middle of the interval. The true mean is going to be that vertical line as marked as 0.5. So let's go ahead and hit sample. And I'm going to zoom in a little bit here so we can see there's my confidence interval, my horizontal line, and my vertical line of 0.5. And so let's go back and some other things we can see over here on the left side. We can see that how many intervals we have containing our true mean rather. I got 1 for 1. Good job, me. So mine did capture the true interval. Yep, mine sure did. I like to change my color to a different color so my teacher can see when I'm actually taking notes because he's colorblind. So I'm going to repeat it 10 times. We're going to see how many capture the true mean. So I'm going to reset it, and we're going to go to 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 of them, and 9 out of the 10 contain the true mean. Yours might be different, and that's okay. We only did it 10 times. I want to sketch to the right what we saw. I kind of want to see it. I kind of want to just go 10 intervals like that. That's what I want to do. 10 intervals, sample. That's what I want to see. Ooh, and I got 10 for 10 this time. Look at me go. Are you guys jealous? It's okay. Don't be jelly. So I'm going to capture that. Copy that real quick. Capture the region. And I want to copy that to my clipboard and then paste it into, there we go. So 10 of mine there fit. I got 10 for 10. 100%. Go me. All right. We did it. So next, we're going to change the intervals to 100. So I'm going to reset now. Go away, me. I can zoom in and I'll go away. Nope, totally didn't go away. Bye-bye. Reset, and we want 100 intervals now. We want to take a sample. So we see all those. These are 100 confidence intervals. And you can see they kind of darken out the ones that are outside of that, that the true mean is outside of. So I have 96 out of 100 for 96%. So I have 96 out of 100. This value should be close to our confidence interval. So all of your values, you're working on this too, should be around 95%. Mine was pretty close. So is this surprising? No, this should not be surprising. This value, the number of confidence intervals that capture the true mean corresponds to the confidence level. So whatever your value is, you'll write down there. You should get around 95%. Next, we're going to change the confidence level to 80% and sample for one interval. So let's take a look and remember what these look like. Let's reset. We want to change this to 80%, and we just want the one interval, and we'll take a sample. And what does it look like happen with that, with the interval? It kind of looks, and it should look like it's more narrow. It gets smaller. So what happens is that the interval is more narrow. It's a smaller range of values. So what happens here is when the confidence level decreases, the interval narrows. So that's an important idea there, that when the confidence level is decreased, our interval narrows. And so let's sample 100 times now. So I'm going to reset here. Sample 100 times at 80%. And we should now see about 80%. Mine was 82%. You can see what yours is. So I had 82 out of 100, so 82%. This value should be around 80%. And this corresponds to our 80% confidence level. So we're going to interpret what this means. So if we sample many times at an 80% confidence, if we sample many times at an 80% confidence level, about 80% will capture the true mean. So if we decrease the confidence level, the interval will narrow. This also holds true the opposite direction when the confidence level increases. So if we make it, if we're more confident that more of them are going to capture the true mean, then what we're doing is we're widening our interval. So you may remember last class we talked about what we need for our interval to be truly confident that your interval captured the mean. If we're looking at test scores and our range goes from 0 to 100 because that's what your interval was, then yeah, we're probably going to be 100% sure that the actual mean falls within there. So if we stretch it out, make the interval wider, that'll be because the confidence level will increase. That'll increase our confidence level. So next we're going to see what happens when we adjust the sample size. So we're going to decrease the sample size from 100 down to 50. And we're going to change it to 20 in sample. So we're going to look at the size of the interval when we're doing that. So I'm going to reset here. Let's go back to, we'll just keep it at 80% right now. And we'll go down to one interval, and we want a sample size of 50. And we'll take that sample. And so what we should see here is that's slightly wider. And then if we go to 20, you can see how that got wider as well. So as we decrease the sample size, the interval gets wider. And the opposite is true as well. If we increased sample size, the interval would get narrower. So the more data we have, the more confident that we are close to the actual mean, the true mean or proportion. The less data we have, the less confident we are. We have to make the interval wider to stretch out to make sure that we have the true mean in our interval. So our learning targets are posted right up here, and we're going to write down some stuff here. So we're going to interpret confidence. In last class, we interpreted confidence interval. Now we're going to interpret confidence level. So if we were to select many random samples from the population and construct a C%, whatever our value is, confidence interval from each sample, about C% of the intervals would capture the true mean or proportion. Scoot that over a bit. So that's the meaning of confidence level. And then we're going to talk about sample size and confidence level, how that affects the shape of our interval. So when we increase the confidence level, we increase the interval, and it gets wider. It widens. If we increase the sample size, n, its confidence level was C%, then we would decrease the interval. It would get narrower. And then the opposite is true as well. If we decrease the confidence level, we decrease the interval and get narrower. If we decrease the sample size, we would increase the size of the interval. It would get wider. So the reverse is true as well. And then finally, sources of bias do affect the margin of error. For example, under coverage, non-response, and response bias. And we've talked about those types of bias before. We can come back and when we talk about number 3 here, kind of think of some ideas of how the margin of error accounted for that bias. So jot all that down, and we'll work on application 7.2, and maybe your teacher will have a math Excel you can work on as well. Otherwise, have a great day.